ドアが開きます。ご注意ください。
Before I start talking about ransomware, I want to make clear that this is an educational video. It is not meant to support or glorify any illegal activity. It's meant to show and explain the inner workings of ransomware. Since this is a simulation, it is simplified compared to real ransomware that you may know like WannaCry, Locky, or Petya. First, we're going to see the ransomware from the victim's perspective. And after that, I'm going to show you what's behind that, the ransomware code. What we see here is the victim's machine. It's a Linux machine inside a virtual machine, and I've prepared 3 files which are going to be encrypted by the ransomware. Why not the entire operating system, the entire disk? It's just because it's faster just to encrypt these 3 files, and that way I can also show you how to target specific files for encryption and decryption. Now you see the first file, it's a PDF containing random text, a text file containing zeros and ones, and an image. They're all located on the victim's desktop. Inside the victim's downloads folder, we see a program called GTA 6 Leaks Trial. Of course, this is fake. It's our ransomware pretending to be something else. Now, when I execute it, we see that something is happening, hopefully. Yes. So our wallpaper having changed is the first sign that our ransomware has finished running. It's just a fun gimmick. Now we already see that our thumbnail has disappeared. When we open the image, it's blank, so it seems that the encryption has worked. Also, the text file is, well, not displayed correctly, and the PDF file, yeah, seems to be corrupt too. In addition, we see that this ransomware node has been created. It contains our ID and a message telling us to open this address in a browser, specifically the Tor browser. It's an onion address, so we have to use the Tor browser to open it, and that's what we are going to do. Now we see that we should enter our ID. If we check the ransomware node, it is 123. And then we get the instructions to how to decrypt our program. In reality, this is usually the point where we have to pay the ransom. Now, since this is a simulation, we'll just continue with the decryption process. The first step is to download the decryption program. So we'll do that, save the file, and continue with step 2. We should navigate to the directory, which we'll do once the download has completed, and open a terminal there. Then we can continue with step 3, which is running this command. This command makes an executable out of our downloaded file. And lastly, we can run this file with our ID. So we see the decryption is running and has finished. If we check our files, we can already see the thumbnail here has appeared again, and it shows correctly. Also, the PDF is fine again, and our text file seems to be decrypted as well. Let's move from the victim's perspective to the attacker's perspective. Our ransomware essentially consists of two files, the ransomware.py, which does the encryption, and decrypt.py, which does the decryption. We'll start with the encryption process. So inside our main function, we can maybe already see the structure, how the encryption process works. We have here the setup of our encryption. Then we'll store our key somewhere on the victim's machine. Then we find out which files we want to encrypt and do the encryption on these files. Then we'll change the wallpaper, which we've seen, on the victim's machine and create a ransom node. I won't explain each line of code, just the most important part of it. The file encryption is done using AES, which is a symmetrical encryption. It is more efficient and faster than asymmetrical encryption, for example, RSA. But the problem is that there's only one key for encryption and decryption, and we don't want our victim to be able to read our encryption key in clear text. So that's why we use RSA to encrypt our AES key. And then we can store this key on the victim's machine without having to worry that the victim can do the encryption him or herself. So here we create our AES key, and then we do the encryption with RSA. We get our RSA key from which was pre-generated, and this can be stored anywhere since it's supposed to be public. We do the encryption of our AES key and then return that key. Then we define the path where we're going to store this AES key. After that, we see something called encrypted files SHA-1. SHA-1 is a hash standard, and this is used for targeting specific files which we want to encrypt or decrypt. If we look at this line, relevant files, we see that we only target specific files which match with a certain hash value. So that's also why we have to store the hash of the encrypted file so we know which files to decrypt again. So we, after storing the AES key encrypted with RSA, getting the relevant files, we start with the encryption. Now we do some logging and change the wallpaper so the victim knows something has happened and create a ransomware node on the victim's desktop. Let's take a look how the decryption works. It is essentially the same thing, but the other way around. So we first get the file hashes which we want to decrypt. They are, as we have seen, stored on the victim's machine in this file. So we'll just read which hashes are in there and then continue reading the files. And then we do the same thing with the AES key, which we also know is stored on the victim's desktop or on the victim's in the victim's home directory. So we'll read this key, then do the decryption using the counterpart of the RSA public key, which is the private key only stored on our side. And then we can return the decrypted AES key and start decrypting the files. Cleanup just removes the nodes and files we've created to help our encryption process. Lastly, I want to show you how the .onion site is hosted. So this is the site that the victim interacted with, which is not in a normal internet network. We see that it has a .onion extension, which indicates it's a hidden service. Usually, ransomware or most of illegal activity is hosted in with hidden services, so they can't be easily be traced back to the hacker. This can be done in another virtual machine. Here it's Kali, where I have Tor running and an HTTP server. Inside this directory where the HTTP server is running, you have the index HTML, which is the website that the victim interacted with. And also we see here the decryption program which the victim used to decrypt its files. Now, this was our simulation. It is simplified compared to real world cases like WannaCry, Locky, or Petya, or there are also many more ransomware out there. But in the main things they do are the same. They encrypt the files using some symmetrical algorithm, and then use an asymmetrical encryption to encrypt this symmetrical encryption algorithm's key. And also for the decryption, we see it's basically the same thing, just the other way around. Use this information to analyze ransomware that's out there to catch bad guys. Don't become the bad guy.